Good morning, my YouTube viewers. It is Crystal here. I'm just here this morning because I wanted to make another video for you. This particular video is going to be about how to do the Anova test in Excel with Python, and I'm going to be going over the one-way test and the two-way test. So basically, what the Anova is, it's the analysis of variance, and it's where you have to test a minimum of 3 samples and find out how their means, are separate, or how their means identify with each other. And so basically what I've done is I've got class 1, class 2, and class 3, and I have arrays of 31. So because with the Anova you have to have at least 30. So A2 to A31 is 30. So the Anova allows you to check the means of minimum of 3 samples, and the samples should be at least 30. So I did 30. And what I did was I checked the means, and what you could do is I checked the means, and these were like grades. These were like students' grades, and I input them all myself. So it wasn't a random number this time. It was just inputs, where I input student grades between, we'll say maybe 60 and 100, because we're going to say that's probably what a student grade is. And so you had class 1, class 2, and class 3, and so you were going to compare the 3 classes. So the means of the 3 classes were: mean 1 was 78.5, mean 2 was 79.16667, and mean 3 was 77.8333. So those were the means of the 3 classes. And then so basically what you're going to do is you're going to compare the means. But I also did the standard deviation for a sample, and I did the variance for a sample as well. And so you can see what the variance is and what the standard deviation is. But I think that what an analysis of variation checks is the mean. So what I did was, we decided we're going to do this in Python because Excel now has Python in it. So we're going to check Python out. Okay, so we come over here, and you can see the code right here, and this is the code that I put in there. So you're going to say class 1 is A1 to B31, headers are true. Class 2 is B1 to B31, headers are true. Class 3 is C1 to C31, headers are true. And then fstat, PV is going to be F1 way, class 1, class 2, and class 3, and then you print out fstat pp. But what you have to do, because we're using the scipy library, so what you have to do is you have to import the scipy library into the program. And how you import the scipy library is in the very first sheet, is the sheet that you import the libraries. And so on cell A2 is where I have imported the scipy libraries. So import scipy, from scipy import stats, from scipy.stats import one way, import F1 way. And then what we're going to also get to, which we're going to be covering it in the next pages, we've also had to import statsmodels, because in the first Anova, which is the one-way test, we use scipy, but the second and third Anovas that I use, you have to use statsmodels. So we import statsmodels.api SSM from statsmodels.formula.api, import OLS, that's ordinary least squares. From statsmodels.stats.anova, import Anova RM. So you can see, and this has to be on the first sheet of the worksheet because Excel will pick that up. So on the first sheet of your worksheet, it's going to be your import values. So now that we've imported values, we type the formula in using Python, and what you do is you click onto the one you have to go into formulas, and then you have to click onto the Python, insert Python, and then whenever you're inserting the code, you're going to get a little green tick mark. And what I did was I clicked onto the green tick mark, and that green tick mark is what activated the code. And if you watch different videos, they'll tell you different things like press Control Enter or something like that, but I just ticked the green tick mark. And then whenever you put the code in, you get this little icon right here where a little square with a bunch of slices in it, and you click onto that, and it'll ask you to view array, and then you click onto view array, and then when you click onto view array, you're going to see that your F statistic is 0.092196, and your p value is 0.912015. So your p value is what you use to determine the null hypothesis. So we'll say that the null hypothesis your null hypothesis are the means are the same, and your alternate hypothesis is the means are not the same. So since and let's see, now it's connecting. And so because the thing is that Python is online, and they've used Anaconda. What Excel has done is Excel has used Anaconda to call the Python in, and Python is online. So because it's online, it's not hard-coded into Excel. Excel is extracting it from Anaconda. So going back to the hypothesis, we have to accept the null hypothesis because the null hypothesis is greater than 0.05, or it could be 0.1, but it's still greater than 0.1. And then so we're going to say that the means are the same. So you've got the means of 78.5, 79, and 77. So you're going to say that the means are very close together. So the null hypothesis is telling you that the means are the same. If the p-value was less than 0.05, or even 0.1 if you wanted 0.1, then you would have to accept the alternate hypothesis, which means the means are not the same. And so I check my work, because in Excel, you actually have a data analysis pack. Now in the data analysis pack, you can do a single factor Anova, which is what I did just to check my work. But the thing is not all Excels are going to have the data analysis pack. But what I'm postulating is that if it's got Python in it, it's probably going to have the data analysis pack. But if you want to check your work, I've used the data analysis pack in Excel, and I've got the F statistic as 0.09216, and the p-value is 0.91205. and it's calculating, but when it finishes calculating, you will see that it is the same. And it does that sometimes because it's online, because um because it's online, sometimes it has difficulties. And that's another problem with Python, is sometimes you can get an error if it says a hash mark Python. Then what that means is there's an error in the code. Or if you get a hash mark value, then what that means is, so let's just clear the contents. So now you've got the tuple. So you come over here, you click onto the little square with the little shells in it, and you go array preview, and you say it's busy, but it will give you your F statistic and your P value. So that's how you calculate an Anova using Python in Excel, and also the data analysis pack in Excel. And it's easier to perform an Anova calculation in Python than it is to do it strictly with Excel, because if you watch one of my previous videos, I actually performed an Anova, and it used a lot of calculations. And here you go, just with Python, and also the data analysis pack. With Python, you just needed to type in the code, and then that would give you the information automatically. And with the data analysis, you just, with a keystroke, and then you just had to say what cells you wanted to compare. So that's it. So now we have the Anova two ways. So the thing about the Anova two ways is that the thing about the Anova two ways is, I'm not sure now on the data analysis pack, they do have a way to do Anova two ways, but they don't have a way to do Anova two ways if it's text. And that's the great thing, the difference between Python and Excel's data analysis pack, as Python will allow you to compare string variables, whereas Excel won't. Excel has to be numeric, and we'll be talking about that shortly. So I did give you another data set with water, sun, and height, where you wanted to compare that. So water and sun, I can't give you the mean, the variance, or the standard deviation because they're not numbers. But the height, I can give you the mean, the variance, and the standard deviation because they are numeric. And you get 30 pieces of data. And then so what we're going to do is we come over here to the Anova two-way, and then we've made another piece of code. So df equals pd dot data frame, df water equals xl a1 to a31 headers equals true, df sun equals xl b1 to b31 headers equals true, df height equals xl c1 to c31 headers equals true. And then model equals, because remember a few minutes ago I said that you had to insert the stats model, you had to import the stats models library into the first sheet of the workbook. So this is it. This is model equals OLS height, and then it says C water plus C sun plus C water to C sun, data equals DF, and then you're going to fit it. So basically what we're doing is we're using a regression model at this time, and then sm.stats.anova ln model type equals 2. So I think that scipy is easier to work with than stats models, and I think that the scipy documentation is more complete than the stats models documentation, because the stats models documentation, they just tell you what the formula is. They just tell you what the function is, and it's up to you to figure everything out. And the way that I get around that is I go onto the internet and I look for sample code, and that's how I find sample code. So I find scipy much easier to work with than stats models, but I just wanted to show you different ways that you could perform an Anova test, and this is an Anova two-way test. I personally haven't found how you can perform an Anova two-way test in stats models. In scipy. If I did find how you could do it in scipy, I would be making this video on scipy and not stats models. So then what we do is we go to the little box with the little shelves in it, and then we click onto array preview, and then when you get the array preview, you get a little box of all of your formulas. And what you want to look at is you want to look at your F statistic and your p-value. So for water, your p-value is 0.0005, so that's going to be less than the alpha, less than 0.05, so that's, you're going to have to accept the null hypothesis. For the sun, it's going to be a really small number, so again, that's going to be less than 0.05. And then for the water, it's going to be 0.12. So you can accept the null hypothesis for the water, but you cannot accept the null hypothesis for the sun and the water. So this is quite complex. This is Anova, and that's basically how you do it. That's what you get. And then the data analysis pack, you definitely can't do this on the data analysis pack because the data analysis pack will only allow you to work on numbers. It will not allow you to work on strings. So we're going to go over here to Anova two-way numeric, and that's exactly the same as the Anova two-way with the numbers, but without the numbers, with the strings. But what I did was, instead of giving it a word, I ordinal encoded it, so it would be like, so I assigned a value of 1 for something, and a value of 2 for something, and a value of 3 for something. So it's exactly the same, except instead of strings, it has numbers. And so the p-value and the statistic is exactly the same as well. I actually did perform a data analysis using Excel's data analysis pack just to check my work, but the figures that I came up with on the data analysis pack were not the same as the figures that I came up with on stats models, so I cleared that data. Another thing that you can do in stat models is you can do repeated measures. And so this is a test where we have repeated measures, where we talk about patient, drug, and response. And this has 20 array of 20 elements. And so you can get the mean from the elements because they're numbers. You can get the variation from the elements because they're numbers, and you can get the standard deviation from the elements and the numbers. So you come over here to where it says Anova results, and then we type in our code as well. So df equals pd dot data frame, df patient equals Excel A1 to A21, headers equals true, df drug equals Excel B1 to B21, headers equals true. DF response equals X1, XL, C1 to C21, headers equals true. And then now what we're going to do is we're going to put in the formula. So model equals Anova RM, and RM stands for repeated measures. Data equals DF, DEP var equals response, subject equals patient, within is your drug, and then you're going to fit it. So this is also a type of regression. And then I put model in, and then when you put model in, you go to the little box with the little slides in it. And when you go to the box with the little slides in it, it'll say like preview string, because the result is a string. But unfortunately, the result didn't give you a nice little square like it did in the previous stats model Anova. It just gave you one string, so it gives you like F value, numerator degree of freedom, denominator degree of freedom, and P value. And then so your F value is 19.9024. Your numerator degree of freedom is 3. Your denominator degree of freedom is 12. And your P value is 0.0001. So your P value is going to be less than your 0.05. So it's not going to fall into the null hypothesis. So because it doesn't fall into the null hypothesis, that means the null hypothesis is the means are the same. Because it doesn't fall into the null hypothesis, you have to accept the alternate hypothesis, which means the means are not the same. So that's it. Unfortunately, that is the output that you got on this stats models. And so obviously, Excel and Python have a lot of work to do to make Python stats models more easy to read. And what you have to do is, if you're really into statistics, then you can study the Anova, and then the Anova one way, the Anova two way, and the Anova repeated measures. And then you can learn everything there is to know about the Anova. And so I've been talking to you for almost 23 minutes. So I've talked about everything that I wanted to talk about. I talked about how the first page of the worksheet has to be to import the libraries. We talked about the Anova one way, the Anova two ways, and the Anova RM, which is repeated measures. So I think we talked about a lot of stuff in this video. So if you like my video, please like and subscribe. Thank you so much for watching my video, and I look forward to communicating with you in another video in the near future.